Hi, this is Manoj. In this video we know different concepts of power factor, such as basics of power factor, how to calculate power factor for a given load, how the solar system affects the power factor of a overall system, role of capacitor bank in improving power factor. As we know, the power factor of an AC electrical power system is defined as the ratio of the active power absorbed by the load to the apparent power flowing in the circuit. Whereas, apparent power is the vector addition of active power and reactive power. And the active power is all to apparent power into cos phi. The reactive power is equals to apparent power into sin phi. To understand the concept of power factor, let us consider a load of motor which is consuming 15 kW active power and 7 kVAr reactive power. As the only power source in this case is grid, the overall load will be consumed from the grid. As we know the kW and kVAr consumption from grid, we need to find apparent power to calculate the power factor of the system. As we know kVA square is equal to kW square plus kVAr square, we can calculate apparent power. kVA square is equal to 15 square plus 7 square, which is equal to 274. And kVA is equal to square root of 274, which is equals to 16.55. So for the above case the load is consuming 16.55 kVA apparent power from the grid. As we know active and apparent power, we can calculate power factor, which is equal to active power divided by apparent power. So power factor is equal to 15 kW divided by 16.55 kVA, which is 0.9. So for the above case the power factor of the system is 0.9. To understand how the solar system affects power factor, let us add 5 kW solar system to the previous example. As solar inverter generates power from solar, it acts as one of the power source to the load. Normal solar inverter will operate at unity power factor, so from inverter we will get only active power. So consumption from grid will be equals to total load minus solar generation from the inverter. Consumption from grid is equals to 15 kW plus 7 kVAr minus 5 kW plus 0 kVAr. Consumption from grid is equals to 10 kW plus 7 kVAr. Means 15 kW of active power load will be shared 5 kW by solar inverter and remaining 10 kW by grid. But as we will not get reactive power from inverter, the overall reactive power load, which is 7 kVAr, will be supplied by grid only. As we know the kW and kVAr consumption from grid, we need to find apparent power to calculate the power factor. As we know kVA square is equal to kW square plus kVAr square, we can calculate apparent power. kVA square is equal to 10 square plus 7 square, which is equal to 149. And kVA is equal to square root of 149, which is equals to 12.2. So after installing solar inverter, apparent power consumption from the grid is 12.2. As we know active and apparent power, we can calculate power factor, which is equal to active power divided by apparent power. So power factor is equal to 10 kW divided by 12.2 kVA, which is 0.81. So for this case the power factor of the system is 0.81. So before installing solar the system consumption power factor is 0.9. After installing solar plant the site consumption power factor is reduced to 0.81. So it is clear that installing solar plant will affect your consumption power factor towards grid. But the rate of reduction in power factor depends on many situations, such as system active and reactive power load consuming, and capacity of solar plant installed. The power factor will not affect where there is a huge load and small capacity solar installed, or solar plants installed in residency where there is negligible consumption of reactive power will be there. We need to improve power factor for maintain necessary grid conditions. To improve power factor, we can use capacitor banks, synchronous condensers, phase advancers, and also in inverters. By making changes in firing angle of switching device we can generate reactive power. so that through inverter also we can maintain system power factor. So to understand the role of capacitor banks in improving the power factor, we will add 2 kVAr capacitor bank to the above system. As capacitor bank acts as source of reactive power, it shares the reactive power load. So the consumption from grid is equals to total load minus solar capacity minus capacitor bank capacity. Consumption from grid is equals to 15 kW plus 7 kVAr load minus 5 kW solar power minus 2 kVAr capacitor bank power. Consumption from grid is equals to 10 kW plus 5 kVAr, which means 15 kilowatts of active power load will be shared by 5 kW of solar and remaining 10 kW will be supplied by grid. Similarly 7 kVAr reactive power load will be shared by 2 kVAr capacitor bank and remaining 5 kVAr will be supplied by grid. As we know kVA square is equal to kW square plus kVAr square, we can calculate apparent power. kVA square is equal to 10 square plus 5 square, which is equal to 125. And kVA is equal to square root of 125, which is equals to 11.1. So after installing capacitor bank, apparent power consumption from the grid is 11.1. As we know active and apparent power, we can calculate power factor, which is equal to active power divided by apparent power. So power factor is equal to 10 kW divided by 11.1 kVA, which is 0.9. So for this case the power factor of the system is 0.9. So before installing capacitor bank the power factor is 0.81. And after installing capacitor banks the power factor is improved to 0.9. So we can conclude that by installing capacitor banks we can improve power factor. Hope this video helped you to understand power factor concept. Thank you.